Hey everyone, Stefan here from Be a Python Dev, back at it with some more Leetcode. This time we're on the strings section of the little mini series thing that we're working for the Explore Easy Problems. This is the reversing a string function, a write a function that reverses a string. The input string is given as an array of characters, character array. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. You may assume all the characters consist of printable ASCII characters. Fun. So example, if you're given hello, you output ole. You can show hint, not going to show a hint. Language of choice, Python 3, because it's always Python at beapython.dev. That's what I like to specialize in, so that's what we're going to be doing. Originally, I solved this. Well, not blah. I solved this already. Apparently, it didn't save, so that's why I didn't have a little checkbox thing. When I submitted it, it worked still, so cool. But I'm going to talk through this. It calls the reverse string function to calculate the solution. It doesn't return anything. You modify s in place. It said that in the it said that in the description already. So Python does this neat little thing where everything is passed by reference. So if you modify things in place, you don't need to return them. The calling function still has access to the modified input data, as long as it's still in the parent scope. I actually did this recursively. I'm not sure why I did this recursively originally. I think you can do this with a two-pointer system. So I'm going to flip it up and I'm going to do the two-pointer system and we're going to see if that works. But I thought I'd just talk about this recursive thing. It's kind of neat. It's not really needed. So if the length is greater than 1, we call the swap characters function. In the swap characters, we pass in the string, and we pass in the starting index that we're looking at for the characters that we're going to swap. We store a temporary character in this TC variable. We switch the end value with the input value, and then we swap the input value with the temp character. And then if we are not halfway through the string, this is our base case, we go ahead and return and break the function. Otherwise, we recursively call it again with an increment of our index up 1. So if this was, we'll just talk about this real quick. If this was 4, after the first pass through of this function, we would have this, where we swap the 0 and the 3 index in these 3 lines right here. And then after the second pass, we would have R, U, O, F. And that would be the reverse value. And then the index that we're looking at is equal to our halfway value minus 1. So that's our base case. And then we would quit calling this. This would be the modified value in place. And then we'd return it. And then everything would be great and happy and grand. And as you can see, accepted. We do a nice little happy dance. But of course, I'm not really happy with that because this is way more complicated, and I'm pretty sure each of these recursive calls adds a function pointer on the stack, which would result in extra memory. Let me see if we... Yeah, so the runtime on this is not the greatest, and the memory usage of this is absolutely horrible, and I think that's because of the recursive call stack. So I'm going to use a two-pointer system. You can also do this with the built-in Python value. I think you can do that. I'm just going to go ahead and do it. There's some optimizations already in the built-in Python function that reverses. It's just this, I think. So let's just run this. Your input, your answer, hello. It's not this, it's -1. All right, this is supposed to reverse it. Why aren't you reversing it? Maybe it doesn't work on strings. Maybe I'm doing this wrong. I don't think I'm doing this wrong. Anyways, all right, we'll pretend that we're not going to use built-in Python functions. So we're going to have a left pointer. We're going to have a right pointer. This is going to equal length of s minus 1. while our left pointer is smaller than the right pointer, we're gonna go ahead and switch them. So SL, SR. So with Python, we don't actually need to do the little temp character variable and all that little complicated assignments. We can just assign these in place. I'm not sure which is more optimal per se if we were doing this competitively. Yeah, because I don't know what magic Python is doing in the background to do this. If you're really concerned with latency, you don't use Python, you use C++. But since I like Python simplicity over crazy syntax that's very optimal, we'll just do this little one-line assignment. And then we do L plus equals 1. R minus equals 1. And this should be all we need, and this should be the two-pointer method. So hello, your answer, ole. Expected answer, ole. Runtime 40 milliseconds. We'll go ahead and submit this. This should always execute, and we should never be in a situation where our indexes are out of bounds. I'm going to feel stupid if I submit this and somehow this happens. Okay, submission result accepted. This should actually be a lot better runtime. Your runtime beats 35% of Python 3 submissions. Again, Leetcode adds false latency sometimes. Okay, so these guys are using the built-in function, which has some C++ optimizations baked into it. There's really no point in doing this except to test your Python function awareness. But if you're actually given this problem in real life, they'd want to see that you understand the arrays and the pointers and how you can traverse through the pointers. Are these all S reverse? S reverse. Are you an S reverse? Left, right. Okay, they did these assignments in one take, but other than that, this is the same one. So awesome there. And then what are these horrible boys? For I in range, n divided by 2. Okay. So this is, they're only going halfway through, and that's not always completely true if you have an odd number. Well, actually it's doing floor division, so it doesn't look at the middle character. But for some reason, this is not as optimal. Why would that be the case? Why would this runtime be 100 milliseconds faster? Interesting. I don't actually know the answer to that. If you do know the answer to it, go ahead and leave something in the comments. I'm interested to hear your take. All right, you are here. Your memory usage beats 49.10% of Python 3 submissions. That's a lot better than that crazy recursion thing I was doing earlier where we were adding extra distribution and memory because of the call stack. I don't know why I was doing that. Apparently I wasn't the only one. It looks like there's some other outliers here. Let's look at these. I want to look at them. It's not letting me look at them. Come on, let me see your code. I just want to see the code. Hey, there we go. All right, we got one. Yeah, so this is actually the recursion thing that I was doing before. They built a reverse function. They didn't do the pre-check for if it's only length 1. If I is less than j, they're also doing 2 pointers, so it's kind of what I was doing, but it's a little more complicated. If you were to do this in an interview and you didn't actually understand that you were creating extra memory from the call stack, that might not look good. But yeah, that's something to be aware of. With recursion, use up extra memory. So it's best if you can do a bottom-up approach where possible. With many depth-first traversals, I don't think you can always do that. So I think you have to use the recursive case there and just take the memory usage in the face. Anything else we got to talk about here, guys? Nope. All right, so we're at 9:50. Thanks for watching along. If you enjoy Python related content, go ahead and like and subscribe to me. We'll be trying to do this at least twice a week. Shoot for more. If I get them likes built up, I'll definitely be doing this more often. I enjoy improving my code skills and improving them with y'all. So take care. Have a great day. Bye.